Hello, my name is Fawaz Anil. My student ID is 114311617, and this is my presentation for the Artificial Neural Network coursework. The title of my project is Human Guided and Gen AI Assisted Neural Networks for Cipher 10 Image Classification and Ambiguity Detection. This is my table of contents, this is my abstract, and this is my introduction of my technical report. The goal of this project was to build and compare two CNN models for the Cipher 10 dataset. The main challenge wasn't just to classify images, but to build models capable of identifying and flagging ambiguous samples, which are basically the images the model is uncertain about. Um, I'll first present a model I built entirely myself, then a second model developed with help from a generative AI, which was namely Grok 3. And then finally, I'll share my critical comparison and reflection on the two approaches. This is the first part, the human-guided model, named Human-Guided Neural Network Design. For this part, I used only my knowledge to design a lightweight 2 CNN layer. Um, so yeah, for this part, I just used my own knowledge to design the two-layer CNN. The architecture was simple. It was intended to create a strong or a solid performance baseline. For ambiguity detection, I used a straightforward confidence threshold, flagging any prediction below 70% confidence. This is the evaluation method. This is the model accuracy and loss. Um, for the results, this model achieved a test accuracy of 70%. And as you can see in the confusion matrix, this is the confusion matrix. Um, it struggled with like visually similar classes. For example, if you look at the true row for cat and dog, and the predicted this is the predicted column for dog. You can see the model's single best error was misclassifying 215 cats as dogs. Um, I'm going to show some images. Here are a few examples of images the model flagged as ambiguous, and where you can see the low confidence scores. And now I'm going to go into the part B. So for part B, I collaborated with AI, namely Grok 3. I prompted it for three main prompts, including suggestions on a more advanced architecture, hyperparameter tuning, and a better way to detect ambiguity. Based on its suggestions, I implemented three main enhancements: a deep three-layer architecture with batch normalization to stabilize training, data augmentation using horizontal flips to help the model generalize better, and a more sophisticated ambiguity metric, namely prediction entropy. This is the ambiguity detection, evaluation method, model accuracy and loss, the prediction of images, the trend prediction of images, confusion matrix. Um, we're going to the class. Yeah, this is the classification reports table. Um, this is the results. Um, this like AI driven changes resulted in a higher test accuracy of 73.77%. The classification report shows the classification. This is the classification report. It shows a much better F1 score for. Sorry, it shows a better F1 score for shape and then to the F1 score for cat, but it still shows that the model was struggling with ambiguous classes like cat. Now we're going to go into the critical comparison and reflection. Um, in terms of like which model was better, the generative AI assisted model clearly outperformed the human guided one, both in accuracy and in its ability to like detect ambiguity using entropy. The performance gain is directly attributable to the advanced techniques suggested by the AI. Um, this is ambiguity detection effectiveness. One thing I would say is that the most important lesson from this project wasn't just that AI helps. It was that the best approach is like the hybrid one. The AI suggested powerful techniques, but it lacked the specific understanding of data set challenges, like the cat and dog problem, for example, which I had identified through my own initial analysis. Um, Human expertise was essential to filter the AI suggestion and apply them effectively. The Grok 3 provided the tools, but human expertise provided the context. In conclusion, this project demonstrated that while a human-first approach provided a solid foundation, collaborating with generative AI can lead to demonstrate a more superior, more robust model. And I believe that the future of effective model design lies in this human and AI partnership. So now I'm going to be switching to the GitHub. Um, as required by the assignments brief, the code for this project was managed in my private GitHub repository, um, which commits to document the development process. However, I would like to add that I began this project using the wrong GitHub link. I used the github.com rather than github.coventry.ac.uk, and I only realized this after Mr. Jeffrey corrected this in class. So I just, um, as advised by Mr. Jeffrey, I just added my files and uploaded it to this correct GitHub, and so yeah, um, this repository includes all my source code and documentation. This is the part A for the human guided, part B for Gen AI assisted. Take a look at the two. And then for my generative AI assisted, see the class distribution, the accuracy loss, the confusion matrix. And yeah, thank you for watching.